Hello, folks. Today, my name is Paul Stasurak. I'm the program manager for storage at Cornelis Networks. With me today is Brian Wilson, our principal engineer, working as the lead engineer working on DAOS support. And I'd like to provide an update on Omni-Path Express support for DAOS. Okay, so moving on, here we go, legalese. And then, so for today's agenda, brief introduction to Cornelis Networks, provide an overview of Omni-Path Express and DAOS on Omni-Path Express, and then DAOS support availability. Okay, so starting off with Cornelis Networks, as many of you may know, the Omni-Path business was spun out from Intel as Cornelis Networks last year. And as you can see here, Cornelis is the latest iteration of a long-running business to built to address and evolve the high-speed interconnect market. Origin of the company started with InfiniBand high-speed interconnects as Silverstorm. QLogic acquired Silverstorm and Pascal for its PSN2, consolidating that in InfiniBand solutions for high-performance compute. Intel saw the value of this and opportunity to address InfiniBand scale limitations for high-performance computing, procuring QLogic and Cray assets to form the Omni-Path product line, complementing their ZN5 strategy. Cornelis will continue to capitalize on this investment and proven Omni-Path technology and leverage all the investments from Intel over the last 10 years. It's a long-running business and strong solution. So, current support for DAOS, I think is mentioned a couple times on some prior presentations. Support for DAOS is on PSN2. Though PSN2 is used, for DAOS development usage, the bottom line here is there are limitations with the implementation. Given these limitations, Sockets has proved to be a suitable alternative to run DAOS and Omni-Path. However, Sockets does not exercise the full performance of the capacity of the fabric. With that in mind, what Cornelis is doing is adding OpenFabrics interfaces libfabric support to Omni-Path. And to underscore the expected performance improvements resulting from this development, we've actually rebranded our solution to Omni-Path Express. We're doing this to take advantage of the significant advancements engineered in OFI libfabric and to drive greater performance on Omni-Path Express, and also to take advantage of contributions to OFI across key contribution across key applications. Benefits of doing this are to take advantage, obviously, of continuous improvements that will be available in libfabric in collaboration with the OFI community. As suggested already, we expect performance improvements across all key metrics: message rate, throughput, latency reductions. Applications optimized for OFI libfabric can take advantage of performance through Omni-Path Express native OFI provider that we're including in Omni-Path Express. And then including the native OFI support in Omni-Path Express provides the low latency communications that DAOS relies on. Okay, just like to briefly provide some context for Omni-Path Express and share the roadmap. Today, Omni-Path 100 hardware supports 100 gigabit per second native fabric interconnect, and is also a 200 gigabit per second capable solution using dual rail configurations. Omni-Path 100 continues to be an industry leader in providing cost-effective high-performance solutions for many customer needs. Omni-Path Express represents the next step of our evolution, and as upgrade of our software infrastructure, taking advantage of the current Open 100 hardware. Omni-Path Express will provide significant performance improvements and expansion of supported applications. As you can see listed here, PCAche, GPU support, AI frameworks, and most importantly for this group, DAOS and object storage. Open 100, 400, the next generation of hardware coming in 2023 is being engineered to provide optimum industry support, supporting for OFI. Okay. So what else is motivating the addition of native libfabric to Omni-Path Express? Application environments have been rapidly evolving, embracing AI techniques and data analytics. In turn, server node architectures are evolving by complementing standard CPUs with accelerators. This combination has created more demanding communication patterns on the fabric. In addition, this has added significant burden to storage, giving rise to object storage systems such as DAOS. All of these changes have driven huge pressure on the interconnect, leading to the creation of OpenFabrics interfaces, highly engineered to meet these and future needs. With Omni-Path Express running OFI natively on today's hardware, we have demonstrated dramatic performance improvements over a prior implementation with PSM2. So let me share some preliminary performance results to show this. With this performance optimized solution using the native OFI provider, the results here shown are from MPI benchmark results, and you can see pretty significant improvements here in performance over our prior PSM2 implementation. Focusing first on the MPI demonstrating latency, message rate, and bandwidth, we're now working to show similar benefits for DAOS. The benefits of DAOS across these metrics are promising, and we're expecting to see some good results here. At this time, I'd like to hand over the next portion of our presentation to our lead developer, Brian Wilson, who's implementing the DAOS support, and to share where we are now with our development. So, Brian.
Hello. Yeah, our development for the Omni-Path Express provider initially focused on Mercury. The Mercury component provides the network abstraction for DAOS, and there was some effort to add the OPX provider to the Mercury capabilities. So adding that table, the provider to the table, providing the functions to manage the OPX address type, went pretty smoothly. There were the Mercury component requires thread safe operations, which is initially not in our function set, so that's been added and is part of the OPX provider in OFI now. The DAOS and Mercury side initially supported only FI context. The OPX provider uses the FI context 2 capabilities for performance optimization, so that has been added to Mercury. Moved up to CART to enable Mercury with the OPX provider, which is another minor change, and then we've shifted focus over to validating those changes. So working with the fairly extensive Mercury test suites to run all that, and now I'm currently working up to bringing up the full DAOS environment and running the CART test cases. The next phase, I think, will be our extending the capabilities to address some of the limitations with the PSM2 provider, namely the persistent addressing for nodes that crash or restarted, make sure that we can reconnect with the same addressing, verifying our fault tolerance and resilience for the dynamic DAOS environment, and looking at multi-tenancy and addressing that. Go to the next slide, Paul. Internally, we're using a 36 node DAOS cluster for the nodes, our servers, running 12 terabytes of Optane SSD and 1.5 terabytes of Optane PMEM. And I thank you to Intel for providing those servers. Our initial development has been based on the DAOS 2.0 development branch, and we'll update that to 2.1. We are happy with the validation progress, and we're currently working with the Mercury v2.1, basically the latest Mercury development branch. The other challenge we have going forward is making some improvements with the build process. The OPX provider brings in a new set of dependencies, and I just need to make sure that we update the DAOS and Mercury build environments accordingly. I think that's it, Paul.
You're on mute, Paul, maybe.
Oh, my apologies. I am on mute. Thank you. Yeah, so the next thing I'd like to share is, where we at with Omni-Path Express availability and then also support for DAOS availability. Currently, our release schedule, we have actually an upstream plan to provide some early drops for demonstrating OpenFabrics on Omni-Path Express. Our first alpha release, it's coming this month. Really, we're targeting this to make sure that we have that available for inclusion in DAOS'22 freeze date, by the end of the year. This is really intended as an evaluation support mechanism for selected customers, but it will be, the pull request will be up there upstream and available. Our second release, the beta release coming in February, will be a performance preview and also demonstrate the improvements we're expecting from our driver enhancements that are in progress. Other elements that are necessary for DAOS, in particular the changes that Brian described, will also need to be upstreamed. That's in progress now. We're working, as Brian mentioned, there are some test environment issues that we're working through to get resolved before we can be able to provide those. But that's all in progress. We expect to have that here before the end of the year. And then ultimately, this will all wind up in our initial Omni-Path Express release targeted for the end of Q1 next year, March 2022. This is our 10.12 release that will include full support for DAOS'22. And then one more point I'd like to emphasize, Cornelis is committed to continuous improvement to bring the best, most performant fabric solution with today's hardware and the next generation of hardware. DAOS is an integral part of this investment and is part of the Omni-Path Express, validation for subsequent leases following on. To do so, requires a commitment to continuous improvement in the Omni-Path Express software stack. Adding DAOS support is just the start, but with continued collaboration and support of Intel and the DAOS community, Cornelis expects DAOS to leverage their best performance on Omni-Path Express. Like, thank you today for allowing us to present our update on the DAOS support we're adding for Omni-Path Express and to share our progress on Omni-Path Express. I'd like to thank the DAOS folks here today and Intel for all their support. If you have any additional needs or want to follow up, please feel free to contact me. My contact information is here. Again, thank you, everybody, and I'll open it up for questions.